Hello, my dear students. Today we'll be taking the lesson of speed, velocity, and acceleration for pre-IG students. This is the lesson content, having all the standards and objectives which we should cover. Let's start with distance and displacement. Distance measures the length from one point to another. As we've discussed in the previous lesson, length has only the magnitude, only the number, so it's a scalar quantity. It's measured in meters or kilometers. On the other hand, we have displacement. Displacement is just like distance. The only difference between them is that displacement measures the length with the direction. So if I say that I've traveled 2 kilometers, that's distance. If I say I've traveled 2 kilometers north, then this is displacement. Since I've included direction, then this becomes a vector quantity. And just like distance, it's measured in meters or kilometers. I want to highlight something, that displacement measures how far are you from the starting point and in which direction. Even though you think that this does not matter for now, but actually it's extremely important, and I'll tell you why in an example. Let's see that a person was driving from their house to school, which was 20 kilometers away, and then they went back and made a stop, let's say at the supermarket, which is 10 kilometers away. If we want to measure the distance, we're going to calculate the total length from the starting point to the end point. So if we're looking at the total length, that's going to be 20 kilometers plus 10 kilometers. So if I'm asked to get the distance, I will say the distance traveled was 30 kilometers. However, for displacement, I need to get the length with the direction, but from the starting point to the end point. So actually, I'm getting the distance from here. The guy went all the way, but where's the end point? It's here. So I only need the distance from the start point to the end point. So if I want to get the displacement, I will not add like I did with the distance, especially that they are in opposite directions. So what am I going to do? Forward, I'll put it as plus. Backwards, since it's in the opposite direction, I'll put it as minus. So my displacement will be plus 20 and minus 10. So this is going to give me 10 kilometers. Which direction? To the right or to the left? To the left. Why to the right, to the left, although he was going back? Because the larger distance was pointing to the left. So from the start point to the end point, I moved towards the left by 10 kilometers. Next, we have speed and velocity. Now that we know what distance and displacement are and the difference between them, that they are both measuring the length or the distance, but displacement has direction, this will help me with speed and velocity. Speed is distance traveled per unit time. It's a scalar quantity because I did not mention any direction, and it's measured in meters per second or kilometers per hour, because distance is in meter or kilometer and time is in seconds or hour. As for velocity, it's the same, but instead of distance, we're going to use displacement because it has direction. So velocity is displacement per unit time. It's a vector quantity, and it's measured also in meters per second or kilometers per hour. Now, this is my equation, whether for speed or velocity, that it is distance over time or displacement over time, as per the magic triangle we have right here. Let me do something with you before we move on by solving the part at the bottom. Let's just analyze this triangle. If I asked you to find speed, you're going to tell me, okay, from this triangle, remember if they're next to each other, then I will need to multiply, and if they're above each other, I'll need to divide. So if I want speed, speed is distance over time, right? Distance and time are above each other. Okay, if I want distance, distance is speed and time are next to each other, so I multiply them. If I want time, look at the magic triangle. Distance is up, speed is down. So it's distance over speed. Okay, I hope that makes it easier. Now let's move on. Look at the example we have. Same example we had in the previous slide, but now they even gave us the time that it's 2 hours. So if I want to get the speed, we said speed is distance over time. My distance was 30 kilometers, and they gave me the time is 2 hours, so that's 30 over 2, 15 kilometers per hour. If I was asked to find the velocity, which is displacement over time, if you remember, we had our displacement to be 10. So it will be 10 over 2, which is 5 kilometers per hour, and velocity is a vector quantity, so I have to write the direction as well, which is to the left. Let's take an example together. Here we have two examples. The first example is telling me a truck travels 110 kilometers. Remember, when we're reading, we always mark what we have and label it. 110 kilometers, that looks like distance. In 2 hours, that's my time. What is the average speed of the truck? Okay, using my equation, speed is distance over time. We're going to put distance as 110 over my time, which is 2. So speed equals distance over time equal 110 over 2 equal 55. Never forget the unit. 55 what? My distance was in kilometers, so that's kilometers. My time was an hour, so that's kilometers per hour. Second example, Jesse throws a ball that moves at an average speed of 35 meters per second. Meters per second. This is speed. And travels for a total of 4.5 seconds. So that's my time. Work out the distance traveled. Okay, so using the magic triangle, distance is speed times time. Remember, I have to look at the units because it will tell me what unit will I put my distance in. Is it in kilometers or meters? Speed here was meters per second, and the time was already seconds. So my distance will obviously be in meters. So let's calculate using the numbers given. Distance is speed times time, so that's 35 times 4.5 equal 157.5 meters. A third example, a car travels at an average speed of 50 kilometers per hour. Here we go, and that's my speed. How long will it take for the car to travel 12.5 kilometers? That's my distance, and they're asking me how long, so they want the time. Using my magic triangle, time is equal to distance over speed. Okay, so let's replace. I have my distance in kilometers and speed in kilometers per hour, so my time is going to be in hours. Now let's just calculate it. Time is distance over speed, 12.5 over 50, which is 0.25 hours. If they asked me to put my time in minutes, as they've done here, I will need to convert this answer in hours to minutes by multiplying by 60, because 1 hour is 60 minutes. So 0.25 times 60 is 15 minutes. Let's move on to the next example. The distance from the Sun to Mars is approximately 210 million kilometers. That's my distance. I want you to remember that they said million, so I will do 210. A million has how many zeros? 6 zeros. So I will multiply times 10 to the power of 6. That will make it easier. Kilometers. What is the speed? So that's what I'm looking for. Of light in kilometers per second. if it takes 11 minutes and 40 seconds. Of course, we've done the lesson of measuring time, and we know how to convert from minutes to seconds. If you can't remember it, please go back to that previous video and look at how it's done. For now, what we need to do is we need to convert these to seconds. So, because I cannot have minutes and seconds, I need to have only 1 unit. So my time is going to be 11 minutes. I need to convert this to seconds by multiplying by 60 and by 40 seconds. That's how I'm going to get my time in seconds. And then I will use my equation, speed equals distance over time, where above I have the 210 times 10 to the power of 6, which they already gave me, over 11 times 60 plus 40, which is my time in seconds, and the answer is 300,000 kilometers per second. Next, we have the distance time graph. You are required here to know 2 things. Number 1, you need to analyze the graph by looking at if the slope is going up, is it horizontal, is it vertical. You should understand what does this indicate. And if they give you values, you have to be able to get the speed or the distance or the time from it. Is it hard? Not at all. It's very, very easy. First, let's start by analyzing the graph. In the first part, let's call it A. The distance is increasing and time is increasing. So obviously, whatever car or person is being labeled here at A in the slope going up, the distance is increasing. That means that this person is moving with time. So here, and it's a straight line. Can you see? The slope is a straight slope. So here it's a constant speed. Can I just write speed? No. Can I just write straight? No. It's a constant speed. Why did we write 30 miles per hour? Because we know that speed is distance over time. So the speed of A is the distance from the start to the end point is how much? 30. So that's 30. And here we go, that's my 30. And what about the time? How long did it take from 12 o'clock till 13 o'clock? That's 1 hour, right? So 30 over 1. And that's how I got the 30 miles per hour. All right, next part, let's look at B. Here, time is passing, as you can see, but he is stopping at 30, distance 30. He didn't move further or closer or anything. So this means that this person, the time is passing by and he's not moving. So here it's stationary. How long did he stay in his place, stopping at the 30 kilometers or 30 miles? How long did he stay there? From 13 till 13 and a half, which is 30 minutes. After that, he's going to go up. The slope is going higher again, and we agreed when the slope is going in a straight line, that's a constant speed. And if I want to calculate the speed there, I have to look at the starting point and the ending point. He started at 30, ended at 40, so my distance is 10. And how long did it take? It took from 13:30, which is here, till 14. That's half an hour. So that's 0.5 of the hours. So over 0.5, which is going to give me 20 miles per hour. In part D, it's a horizontal line, and we agreed that when it's a horizontal line, that means he stayed at that certain distance, he didn't move further, and the time is passing by, which means it's been stationary. How long did he stay in his place stationary? From 14 all the way to 15, so that's 1 hour. Part E, the last part, the slope is going down. So is it in a straight line? Yes, it is, which says, just like inclining, it's declining. That's a constant speed. If I asked you to get the speed for part E, you're going to say, that's easy, speed is equal to, again, distance over time. What was the distance covered from the start to the end? He was at 40 and went all the way back to 0. So that's 40 over. How long did that take? 1 hour. So 40 miles per hour. Okay. Here's a question. Here I have a graph of a student walking out of the classroom, stops to talk to some friends, and then walks to their next class. Describe the motion of the student between time 0 and time 6. I have 3 things that happen that they're trying to explain to me in the graph. The student walks out of the classroom, stops to talk to some friends, walks to the next class. So we have 3 parts. So from A to B, that was the first part. Student walks out of a classroom. And then they said he stopped, and we agreed that when he stops, that's a horizontal line. So clearly, it's from B to C. And finally, walks to their next class. So moving further, that's C to D. Okay, now let's read the questions now that we've analyzed our graph. Describe the motion of the student between time 0 and time 6. So from here all the way to 6, which means A to B, we're going to write student walks out of a classroom. Okay, so it's this one. Calculate the speed of the student between time 0 and 6. Now I need to calculate the speed. So I'll say, okay, speed is distance over time. My distance from 0 to 6, which is still here, is 12 meters. And the time is 6 seconds. So I will have 2 meters per second. For the next part, determine the length of, and they already gave me the unit, which we're good with. Determine the length of time for which the student stops walking. When did we say he stopped walking? From B to C. How long did that take? We started at 6 and it stopped here between 10 and 12, which is at 11. So how many seconds are these from 6 to 11? We have 5 seconds. Compare the student's speed in section AB with the speed in section CD. The more the slope is inclined or steep, that means that the speed is faster. So which one is faster? AB. Which one is more steep? Steep means it's going towards a vertical line. Which one is more steep? AB or CD? AB. AB is steeper than CD. It's closer to the vertical line. So therefore, AB is faster. Then I should never have incomplete answers. I need to write a full sentence. AB is faster than CD. Let's check out the marking scheme. For the first part, we're going to write walking with constant, steady, or uniform speed. So the motion, when he's walking out of the classroom from A to B, he's walking with we already said, if it's a straight slope, then it's a constant speed. Second part, part B, 2 meters per second. It's for 3 marks. So I get 1 mark for my final answer, 1 mark for my steps, and 1 mark to show that I was able to get my answer using the gradient of the distance time graph. Okay? Finally, and what's the meaning of gradient? If someone does not remember, gradient is when I measure the distance over the time. Rise over run. For part C, determine the length. As we've said, it's 5 seconds. And finally, AB is faster than CD. You can use the word faster, you can use the word more, but you have to mention AB and CD. Now we're going to talk about acceleration. We took steady speed and we took stationary. What about the speed if it's going to go faster? Acceleration is the change in velocity, which is the same as speed but with direction. Change in velocity per time. You said direction? Yes, I did. So is acceleration scalar or vector? If it has direction, velocity, then it's vector. So acceleration is change in velocity per time. It's measured in meters per second squared. I'm confused. Don't be confused. We said it's the change in velocity, which is just like speed, distance over time, per time, over time. So that's like distance over time squared. Distance is measured in meter. Time is measured in second. So meters per second squared. I'm just trying to explain to you where we got the unit from. Okay? Okay. So if I'm speeding up, I'm accelerating. If I'm slowing down, I'm decelerating. If I'm at a constant speed, that means I'm not speeding up or slowing down, then I have no acceleration. My acceleration is 0. So let's check how this means when we're talking about acceleration in terms of free fall. Since if something is changing speed per time is acceleration, then falling down is also acceleration, right? Because you were, for example, on a plane and then you jumped with your parachute. So you're going to be accelerating falling down. What if nothing holds you back? There's no friction, no air. This is what we call free fall. The only force that's pulling you down is gravity. There is nothing stopping you or slowing you down. On Earth, gravity gives every freely falling object the same constant acceleration, which is 9.8 meters per second squared. So if I tell you that I want you to get me the gravity on Earth is always 9.8 meters per second squared. This is a constant that you have to know by heart. We finished the distance time graph. I want you now to look at the speed or the velocity time graph. Remember to always look at the labels so you do not analyze the graph in a wrong way. For the velocity or the speed time graph, now the speed is increasing. What did we say about increasing speed? That it's accelerating, right? So as he's going up, he's accelerating. Okay, now he's moving at a constant velocity or at constant speed. Imagine if you're driving a car and you are driving at 60 kilometers per hour. You're staying steady at that certain speed. Then you are moving with constant speed. Now you're going up again, acceleration. And now you're going down, deceleration. So be very, very, very careful with the graphs because velocity time graph is different than distance time graph. So you need to go back again in the video and check them both out to remember the difference. If I want to calculate distance from a speed time graph or a velocity time graph, I need to get the area under the graph. How? We only have 2 rules. If I want to get the area under this triangle, so if they told me to find the distance for the first 4 seconds, distance for the first 4 seconds, what do I do? Here's my 4. So I need to get the distance from the starting point till 4 seconds. Is this a triangle or a rectangle? This is a triangle. What's the rule of the triangle to get the distance? To get the distance, half times base times height. You took it in math. We're doing it again in physics. Half times base times height. So it's going to be half times, what's my base? From 0 to 4, that's 4. What's my height? From 0 to 3, so that's 3. So half times 4 times 3, which is equal to 6. 6 what? I'm getting distance, so that's meters. Okay? All right, what if they asked me to get the distance from 4 to 6? Here. What's the rule? This is a rectangle or a triangle? It's a rectangle. How to get the distance for the rectangle? Just base times height. So I'm going to get base times height. So my distance here is base times height. My base is from 4 to 6, which is 2, times height from 0 to 3, which is 3. So my distance is 6 meters. Okay? These are the 2 rules to get the distance from a velocity time graph or a speed time graph. Let's try to do it together. Find the total distance. They gave you the diagram. Of course, they will not do the breakpoints with the dashed lines like we've done here. We've done it to make it easier for us. We broke it down into how many? Into 1, 2, 3, 4, 5 diagrams. 1, 4, and 5 are triangles, right angle triangles. 2 and 3 are rectangles. So let's get the total distance. Can't I just say speed 25 and time is 50, and distance is equal to speed times time, which is 25 times 50? No, you cannot. You have to break down your graph. So let's do it now. So for part 1, it's a triangle. So I'll do the half times base times height, which is half times 10 times 15, and it gave me 75. For area under 2, it's a rectangle, sorry. So what am I going to do? Rectangle rule is base times height. So from 10 to 20, here's 10, and the height is 15. So 10 times 15, I got it as 150. For the third part, I think they did this as number 3 and this is number 4, so we don't get confused. So number 3, which is the top triangle, half times base times height. And number 4, which is down, it's a rectangle. And number 5 is a triangle. We're going to follow the same thing until we get all the answers. When I have all the answers, I will just add them all together. My final answer, 675 meters, because we're getting the distance. Next example, I have a speed-time graph, speed and time. Determine the speed of the ball at time 1 second. So at 1 second, how much was the speed? I'll use a ruler, go all the way up, okay? And then get my speed. You have to use a ruler so you don't get the wrong values. Describe the speed and get the speed here from the graph. So as per the graph, it's 3.55. Why 55? Because as you can see, it stopped somewhere here in between. So this is 3.5, and this is 3.6, and it's in between. So 3.55 meters per second. Try not to get mistakes because sometimes you do not have room for error, so use a ruler, please. Part B, describe the speed of the ball between 2 seconds and 5 seconds. So from 2 seconds to 5 seconds. So from here to here. What do they want? They want my speed. What was the speed? Do you see any change in the speed? No, the speed is not moving. The guy is just moving at 4 meters per second. He did not accelerate or decelerate. So is there any change in speed? There's absolutely no change in speed. Change in speed is, you can either say constant speed or you can say no acceleration. But of course, the better answer is constant speed. Okay, next, part C. Why can't I write a number? Because they said describe, they didn't say calculate. Part C, calculate the distance moved by the ball between 2 and 5 seconds. So from 2 to 5 seconds, we need to draw a line so we can know what shape we have. What shape do I have? Triangle or a rectangle? It's a rectangle. What was the rule? Base times height. So what will I do from 2 to 5? This one is 3. And the height is this one, which is 4. So 3 times 4, which is equal to 12. 12 meters. That's all for today. Wishing you all the best. See you next lesson.